So today we're starting our first day practicing solving trig equations. Okay, so we're just going to practice the basic algebra steps that we're doing and using the unit circle to find our solutions. Okay, so for most of these problems, we're going just to find the solutions between 0 and 2 pi. Okay, we'll talk more about the infinite solutions later, because technically there are coterminal angles that we need to include outside of 0 to 2 pi, but for right now we're just going to focus on the algebra and using the unit circle to find those values. So we're going to start with something easy, something simple. Okay, so 2 cosine squared x minus 1. So basically the steps in solving a trig equation are basically the same steps in solving any equation. Step 1, set your equation equal to 0. Step 2 is usually to factor. And the first step in factoring is greatest common factor, and then binomial factoring and trinomial factoring. Okay? Step 3 is setting your factors equal to 0 and solving. Setting factors to 0. Okay? Those are the usual steps. Okay? And that's for algebra, just regular algebra solutions or trig solutions. Okay? It doesn't matter. First is always to set it equal to 0. Factor if you can. If you can't, if it only has one x term, then you don't need to do step 2. You can actually just solve from there. And that's actually where we're at in this problem. There's not really any factoring I can do. It's already set equal to 0. I only have one x term, which means I can isolate it easily without factoring. You could force factor this because it is a difference of 2 squares, but it's going to be way easier just solving it. Okay? So that's what we're going to do. We're going to add 1 to both sides and get 2 cosine squared x equals 1. Divide both sides by 2. You're going to get cosine squared x equals 1/2. Then, to get rid of the squared, use square root. That means you're going to get cosine x equals plus or minus the square root of 1/2. And I'm going to do this right over here just so you can see. This is the same thing as 1 over the square root of 2. Because when you square root a fraction like that, you can actually split it up and square root the top and square root the bottom. And the square root of 1 is 1. And we've done this before. When you rationalize the denominator, you get the square root of 2 over 2. So you need to recognize when you end up with this, the square root of 1/2 like that, that's really the same thing as root 2 over 2, so that we can use our unit circle easier. So this is really plus or minus root 2 over 2 to make it easier. So now that I've got my solutions I'm looking for, now I have to use the unit circle. So we go to our unit circle and we say, okay, where is cosine square root of 2 over 2? So we use our reference angle in our first quadrant. So in the first quadrant, what angle is cosine root 2 over 2? And that's at pi over 4. Now, since I'm looking for both the positive and the negative cosine values of square root of 2 over 2, that means I'm going to be using the pi over 4 from every quadrant. If it were the positive ones, I'd only be doing quadrant 1 and 1 and 4. And if it were the negative ones, I'd be doing 2 and 3. But since I need positive and negative, I'm using all of them. So all 4 quadrants that have pi over 4. So 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, So it actually has 4 solutions. 2 for the positive ones, 2 for the negative ones. Okay? So again, the hardest part about this is getting your solutions from the unit circle. All right? Now, let's look at our next one. 2 sine minus tangent equals 0. So, following our steps, step 1 equal to 0. We've already got that. Step 2 is doing any kind of factoring. Right off the bat, I don't see any kind of factoring that I can do I? So if I can't factor and I can't split these up, there's got to be something else I can do. And this is where our last unit comes into play. Our identities. We're actually going to use an identity to help us factor. So what we're going to do is we're going to use this identity. We're either going to use this one, where tangent is sine over cosine, or even better, we could use this one, sine x secant x. And that's how I'm going to change it to make it easier on myself. So I'm going to rewrite this as 2 sine x minus sine x secant x equals 0. And the whole reason for that is because now I can see that I have a factor of sine in both of my terms. So since I'm factoring, my first step is greatest common factor. And the greatest common factor here is sine x, which I'm left with 2 minus secant x. So sometimes when we have to do the factoring, we need to use an identity to help us out. Okay? So, here we go. Next step is to set our factors equal to 0. So sine x equals 0, and 2 minus secant x equals to 0. So I'm looking where sine x is 0, or I'm looking for where secant is equal to 2. Okay? Now, sine x equal to 0, that's easy. That's at 0, pi, and 2 pi. Okay? From the unit circle. Now, 2 secant, that's a little bit more difficult because I don't really know secant values in the unit circle. I know sine and I know cosine. So to make it easier on myself, what I'm going to do is I'm going to change secant into terms of cosine. Okay? Now, there's one rule in algebra that stands above all else. Whatever you do to one side, you have to do to the other side. And I can do anything I want to both sides, as long as I do it to both sides. Okay? So what I'm going to do is to change secant to cosine, I'm going to take the reciprocal of both sides. So basically what I'm saying is I'm going to change this to secant over 1 and take the reciprocal, which is 1 over secant, which is cosine. That's what I'm going to do. But if I do it to my right side, I got to do it to the left side as well. So I'm going to take the reciprocal of both sides, which means I get 1/2 equals cosine x. So finding where secant is equal to 2 is the same thing as finding where cosine is 1/2 to make my life easier. Okay? So here we go. Where is cosine 1/2? Well, we go to our first quadrant. In the first quadrant, cosine is 1/2 at pi over 3. So that's my reference angle, pi over 3. But it's also positive 1/2 in the fourth quadrant. And the angle in the fourth quadrant, it's pi over 3, is 5 pi over 3. So those are my 2 solutions for that one. And those are my 5 solutions. So again, we are going to be using some of those really simple identities to help us out, okay? But that's solving trig equations. Hardest part is probably finding the solutions from a unit circle. The code for today is going to be PR3C4L.